All right, let's look at the vector operator. All right, this upside down triangle is called nabla. So maybe I should write that down. All right, nabla. Right, is you can think of it as a vector operator, and the first component is partial with respect to x, second component is the partial with respect to y, and the third component is partial with respect to z. Alright, so then you can make sense out of gradient. So if you have a real valued function of 3 variables, and if you apply vector operator, we know that we take the, as we know, partial of f with respect to x is the first component, and the second component is going to be a partial of f with respect to y, and then third component is a partial of f with respect to z. Right? And another one is called the divergence. So notation is nabla with the dot product. Let's say you have a vector valued function of 3 variables. So first component is called v1, and second component is v2, and third component is v3. So if you take the divergence, so you have a nabla with the dot product, it's going to be, we take the first component, so it's going to be v1, and then partial with respect to x. Then since this is the dot product, so we're going to apply like a dot product, so it's going to be addition. Then you take the partial of v2 with respect to y, and the partial of v3 with respect to z, then add them all together. Right? So that's the definition of divergence. And we'll talk about the meaning of divergence in the next video. But let's try to compute the the divergence of an actual function. All right. So in this case, so we're applying partial derivative. So maybe I should write that partial with respect to x of x squared. Then we add the partial with respect to y of xy, and then we add the partial of z of xyz. Right? So this is going to be, partial of x squared with respect to x is 2x, and partial of xy with respect to y would be just going to be x. Partial of xyz with respect to z would be xy. So we get 3x plus xy. Right? So this is the value of, this is the divergence of this given function v. Right? That's it. I hope that this was clear.